Topic of this presentation is gas turbine. I will start with main contents and then will explain all contents briefly. So the main contents are: Introduction to gas turbines, basic components of a gas turbine, thermodynamic processes in a gas turbine, types of gas turbines, applications of gas turbines, advantages and disadvantages of gas turbines, gas turbine maintenance and troubleshooting. A gas turbine or gas turbine engine, by its old name internal combustion turbine, is a type of continuous flow. Internal combustion engine is a type of IC engine that uses compressed gas to generate mechanical power. This mechanical power is further used to run a gas generator which converts this mechanical power into electricity. A gas turbine is a rotary machine in which the chemical energy of the fuel is converted into mechanical energy or kinetic energy in terms of shaft power. In other words, it is a mechanical power or thrust-delivering machine. It uses a gaseous working fluid for this purpose. The gas turbine works on the base of the Brayton cycle. During this cycle, the air-fuel mixture is pressurized, burned, passed through a gas turbine, and discharged. In the working cycle of a gas turbine, air uses as a working medium. Following are the working stages for gas turbine: suction process, compression process, combustion process, turbine section, and finally, electricity generation. First of all, the turbine sucks air from the atmosphere and sends this air to the compressor is called suction process. And then in compression process the air enters the compressor. It compresses the air and converts the air kinetic energy into pressure energy. After this, it converts the air into high pressure air. After the compression process, the compressed air enters the combustion chamber. In the combustion chamber, an injector injects gas into the chamber, which is mixed with the compressed air. After the mixing process, the combustion chamber ignites the air-fuel mixture. Due to the ignition process, the air-fuel mixture converts into high-pressure and high-temperature gases. Then in turbine section some energy of the gas transforms into mechanical energy, and some energy is exhausted. As the combustion gas expands through the turbine, it rotates the turbine blades. The rotating blades have a dual function. They run the compressor to draw in more air for operation and also drive a gas generator connected to the turbine. And finally a generator is connected to the shaft of the turbine which receives mechanical energy from the turbine and converts this energy into electrical power. Useless energy is removed from exhaust gases. The exhaust gas is used for external tasks like generating thrust directly in a turbojet engine or rotating a second independent turbine, referred to as a power turbine, that can be connected to an electric generator, propeller, or fan. A working cycle of the gas turbine is explained here with the help of the PV diagram. Compression, combustion, and expansion can be understood easily through it. The gas turbine has the following basic parts: turbine, compressor, shaft, combustion chamber, gearbox, exhaust. Turbine section contains a series of fixed and rotating blades. As the hot flue gases expand through the turbine, they strike the turbine blades and force them to rotate. The rotary blades have two functions. Firstly, it enables the compressor to draw more compressed air into the combustion chamber. It rotates the generator to generate electrical energy. The compressor is one of the most vital components of gas turbines. The compressor is used to compress the air. It sucks air from the atmosphere. As the air enters the compression chamber, the compressor pressurizes the air and increases its pressure according to the turbine requirements. Finally, the compressor sends air into the combustion chamber at a rate of hundreds of miles per hour. The rotating shaft allows the compressor to continuously suck air and pressurize more air for regulating continuous combustion. The shaft takes power from the turbine. It rotates with the rotation of the turbine blades. Some power of the shaft is utilized to run the generator to generate electrical power, while the remaining power is used to run the compressor. A combustion chamber consists of a series of injectors that inject a steady fuel stream into the combustion system and mix it with the combustion chamber's air. The mixture burns at a temperature above 2000 degrees Fahrenheit. The combustion chamber is also one of the essential parts of the gas turbine. It produces a high-pressure and high-pressure gas flow that enters the turbine and partially expands. The gearbox of the turbine provides torque to the driven equipment. And the exhaust uses to expel useless gases from the turbine to the environment. There are multiple types of gas turbines. The most common types of the gas turbine are turboprop engine, jet engine, turbojet, turbofan, turboshaft, aeroderivative turbine, microturbines. For detailed study of all these types of turbines, keep watching my next videos because I will upload them one by one. Following are some applications of gas turbines. Gas turbines are frequently used to generate electrical power in power plants, particularly for emergency backup and high power demands. Gas turbines are used in military applications for auxiliary power units, APUs, propulsion systems, and power generation. They power different marine propulsion systems for ships, such as ferries, cruise ships, and naval vessels. They are employed in aircraft engines to supply the power required for flight. These turbines are also employed in APUs to deliver electrical power and air conditioning while the airplane is on the ground. Gas turbines are employed in the oil and gas industry for different purposes, such as providing emergency power, powering drilling rigs, and pumping and compressing natural gas. You can also use them for district heating and cooling systems to deliver electricity, cooling, and heating to houses and offices. They are employed in various industrial machinery, including pumps, compressors, and generators. Gas turbines may also be utilized in combined heat and power, CHP, systems to supply both thermal energy and electricity for various processes. Among the advantages of gas turbines are fuel flexibility. They have the ability to start quickly. You can also bring them online or take them offline quickly. These features of the gas turbines make them best suitable for use in power plants that need to respond to changing demand. High efficiency. Low emissions. Lower maintenance costs. Lower water consumption. Smaller footprint. Easy installation. Disadvantages of gas turbines are high initial cost, air pollution, noise production, low efficiency, regular maintenance requirements, dependence on external factors. Regular maintenance is essential to ensure the smooth functioning of gas turbines. It includes cleaning, inspection, and replacement of parts as needed. Condition monitoring is a crucial aspect of gas turbine maintenance. It involves the use of sensors and other tools to detect any signs of wear and tear in the turbine components. Troubleshooting is the process of identifying and resolving issues with the gas turbine. It can involve a range of activities, from checking the fuel supply to inspecting the compressor blades. Safety is a top priority when it comes to gas turbine maintenance and troubleshooting. It is important to follow all safety guidelines and procedures to prevent accidents and injuries. Thanks for watching. That's all for today's video on gas turbines. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.